I've been told that my nice guy thin veneer really covers a deep core of evilness, and that this roller coaster ride is a manifestation of that evilness. This is a 1,400-foot long roller coaster track for cars. We've got two two-way teeters, one three-way teeter, an inverse camber, a correct camber, and tipping bumps that are in sine waves that tip you more the harder or faster that you hit them. It's a difficult course, but we tried to make it as safe as possible, and I'm going to show you some of the techniques we use to do that. The reason that we use teeters is to provide an analogy for actually being launched in a roller coaster. Roller coasters start out where you're in the car, it goes up, it hooks into a chain, and it pulls you to the top, and once you go over the top, you begin your journey down the roller coaster. Here, we can't have chains, so you actually have to drive up to the top. You get over center and you drop down, and you're in a position to actually scoot down the course as fast as possible. This is teeter number one. Teeter number one is the one we call the easy teeter. The reason it's the easy teeter is because it has a high pivot. That means you don't have to go very far before it actually starts rocking. It's more like a balance beam. I'm walking up this teeter, and I can actually balance it by walking out to the end. At the end, what you see here is we have a bump beyond which you shouldn't travel. And you can see why. I've already rotated it down with my own weight. We have two flags here that indicate to the drivers how far they're legally allowed to go without losing points. But this teeter goes over very easy. To make it even easier, we'll show you when we go down some plungers that we've designed. They're large drums filled with water that have a plunger in them that actually soften the fall even further. But if you're really careful, you can actually drive over here slow enough so that it doesn't even splash water out. But if you do that, you're going too slow and you'll probably lose. I love this thing. This is the infamous inverse camber, meaning that it's angled in the wrong direction based on your direction of travel. The camber should be this way because you're going in this direction on the curve. It's actually angled this way. The faster that you go, the more it makes you want to slide off. To make it a little bit easier, we've added a non-skid surface here to make sure that it's not, when it's wet, that you can still grip on here. We've also put these log bits on here so that you can actually hook it. In constructing it, we put in a path so that you could make it. Not all the competitors know that it's here, but there's a path that goes along. If you hook your lower wheel in, you can actually make it around quite easily. Penalties are awarded if your wheel goes above the white line on the top, or if you slide off with your lower wheel on the bottom. There's also a white line. Depending on the segment that you're in, you lose points. Points in terms of time of your run. This has proved to be quite difficult over here and has determined the outcomes of several competitions on roller coaster by penalties being awarded or kept away from the competitors. This is the number two teeter. The difference between this teeter and the number one teeter is the pivot on this one is located on the ground. The significance of that is that you have to go much further out before the teeter begins to rotate, begins to actually drop. So because you're further out and it begins to drop and you can't stop it because you've gone over center and there's more energy to dissipate, on this teeter we actually have 4 water dissipator barrels on this one, which is double the amount that we have on the number one teeter. When a vehicle drives up on a teeter, it increases its potential energy. When it falls, kinetic energy develops, meaning there's a velocity to that mass. We need to dissipate as much energy as possible before the vehicle hits, otherwise they hit with a really hard impact. An easy way to do that is to provide a liquid that is forced out of these barrels. So we have plungers built into the teeters that actually push into the barrel, forcing the water to be ejected in this direction. That has 2 effects. It cushions the fall of the teeter, and it also produces a very spectacular explosion of water. So, 2 birds with 1 stone. Clever, huh? Each one of the teeters, number 1 and number 2, have a safety gate on. The safety gate is in the up position to prevent a car from driving into it. So it can't rotate back in this direction, otherwise the car would be able to go right through it. It actually has to rotate in this direction. So you can see that the gate is actually down against the roadbed here, having been kicked out by the feet that are in front of it, so that the feet actually hit, rotate the bar down in this direction. The vehicle can drive across the top and continue on its way through the roller coaster. This is a 3-way teeter. Why do we have a 3-way teeter? Because the executive producer said that it'd be a good idea to have a 3-way teeter, And giving that sort of a challenge to an engineer is like throwing a pork chop to a chihuahua. So we have a very nice three-way teeter. The object of the three-way teeter is to get across it correctly and come out on the right side, following a road path. You can go the wrong way and you wind up going in the wrong direction. So the way the three-way teeter works, it's much like a dish plate that's mounted on a post. You can go up, and if you go too far, it goes in the wrong direction. Or if you go up and you go in the right direction, it falls in the correct location and you can continue on your journey on the coaster. What you're looking at here is the spherical bearing that the three-way teeter rotates on. You can see the large spherical end piece that's mounted on a piece of steel. The steel actually has a ring cut in it, so there's a cup there. So the bearing actually fits into the cup and it can rotate in all directions. Actually, what it does, though, is we limit it to rotate either in the direction that is going on the roadbed or in the other direction. So there's 3 positions that the teeter can actually land in. We have legs built on the teeter so that it won't land in any other except those 3 positions. A normal spherical bearing of that size is going to be extremely expensive, so we had to figure out a way to make it do it, to actually construct one inexpensively. So what you see there is actually a 12-inch pipe cap set into a 1-inch thick piece of steel with a hole cut in the steel, and it actually works quite well. It's greased up. The entire 1,400-foot length of roller coaster is covered with sheets of plywood. The plywood forms the roadbed surface that the drivers actually go on. The plywood surface is 2 sheets of 3/4-inch plywood screwed together on top of sleepers or other supports. But plywood's quite flexible, so as the vehicles go across it, they produce a creaking noise, which gives the illusion that the roadbed isn't quite as sturdy as it should be for the drivers. So it's much like a wooden roller coaster as you're going across that. It creaks quite a bit with the cars, really not unsafe, but it gives the illusion of imminent collapse. And one of the things we like to do after the drivers have gone around over the bumps is we search the track for coinage which falls out of their pockets. And I've just found 20 pence.